Okay, and for these last two examples, let's see how these are. So the limit is x approaches 5. Guess what? If you plug in, you get 0 over 0. All right, well, this is not something where we would factor, but rather this is, some fractions or what are called complex fractions. So this is where I use that phrase, clear the denominators. There's a couple different ways you could think about it, but denominators, okay. All right, so what I would do is I'm going to say that this equals the limit as x approaches 5. And what I'm going to do is I'm going to take the big fraction and I'm going to multiply the entire big fraction by something that will clear all little denominators. And my two little denominators are x minus 1 and 4. So I'm going to multiply by 4x minus 1, but I have to do it to both the numerator and the denominator. All right, so I guess I'll put a big parentheses around that. Okay, so now let's see what happens when I do this technique. Okay, well, in the numerator, so now I'm going to distribute to both fractions. Well, in the first fraction, the x minus 1s would cancel, so I'm just going to have 4, and you know I'm writing that limit first. So that's 4 minus, and then for the second fraction, the 4s would cancel, and so very important parentheses, x minus 1. Okay, all over. And then the denominator, nothing cancels, so that's going to be a 4, the x minus 5, and the x minus 1. And it looks really ugly right now. You're like, how is this making anything nicer? Well, let's see. What is that numerator? And it's kind of just a beautiful thing. It always works out this way. Is that numerator, so again, still the limit. Well, that's negative x, and then plus 1, plus 4, plus 5. Okay, and some of you might even see it already. I'm going to show one more step. I'm just going to do it to the right here. What is that numerator? It's not x minus 5, but it's the opposite, right? So if I factor out that negative, that's the opposite of x minus 5. And so here we go, big finish. The x minus 5s cancel, and that equals the limit. I know you're like, gosh, you have to write the limit every single time. Oh yeah. Calculus, we're going to make you do it every single time. And yeah, it's because it's not mathematically correct if you don't write the limit at every step. So I've done all these limits with the fractions, the clearing, the simplifying, the factoring. And now, at this step, now I'm going to plug in 5 and get negative 1 over 4 times, 4. So the answer is negative 1 over 16. Cool, 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 cool. All right, and the last one I just threw in as a fun little go down memory lane here. If you plug in 2 pi, you'll get the sine of 4 pi over the sine of 2 pi, and that's 0 over 0. Now, only because this is something we know can we go, hey, I remember my trig properties. Do you remember your trig properties? We spent a lot of time on it. Sine of 2x, sine of 2 theta was 2 sine cosine. 2 sine cosine over sine of x. All right, so this was just kind of a cute one to remember. See if you remembered that property. And so that's the limit as x approaches 2 pi of 2 cosine x. And now we plug in 2 pi. And so 2 times the cosine of 2 pi. The cosine of 2 pi is 1, so that equals 2. All right, and that's the end of it. I know there was a lot of notes and a lot of practice. Again, this is just, a good head start for calculus next year and just for you to really have all these algebra techniques down with the factoring and the conjugates and all that, all the fractions. Just good for you to have that practice now. Okay, so hopefully it made sense. Again, go back and watch the video if it didn't, and you can work through the notes again. And good luck on your homework. Take care. Have a good day.